welcome back. In today's lecture, I am going to talk about limit cycle. Okay, and again, I am going to use the idea of phase plane analysis, and I am going to limit myself for second order autonomous dynamical system. So, one of the very important phenomenon that occur inside dynamical system theory, that is called oscillation. Okay, so let us try to see that basically how to define that oscillation. So this is the first definition. So a system oscillate when it has a non-trivial periodic solution. Okay, and I hope that you all of you are already aware what is meaning of periodic functions. Okay, so whenever I have some function that is called periodic function, if you take some kind of shifting by t, then we are getting same function. Okay, here since I am going to talk about two-dimensional system, so it might possible that I have some kind of function like f1 f2, okay, or a state you can define x1 x2 like this. So whenever we have some kind of periodic solution, at that time it is possible to show that for all t there exists some time t such that this relation is going to hold. If this relation is going to hold, then we are telling that whatever system or whatever dynamical system that is going to oscillate, and it is possible to show that this is not a trivial solution, that is non-trivial solution. What is meaning of non-trivial? So here, if you have seen the dynamical system till now, I have defined the notion of equilibrium point, and what basically we have discussed that equilibrium point is nothing but some kind of solution in the phase plane or in a state space. If you start from there, you are going to stay there forever if there is no external force, or external force is not going to act. That kind of definition we have seen. But here it is possible to show that some classes of system has some different kind of solution than equilibrium point, and here property remains the same. What kind of property is there? If I have some kind of non-trivial solution, you can tell that if you start from that set, you are going to remain inside that set. So I have some kind of invariant set. Okay, invariant means if you start from some set and you are going to stay there forever. So instead of the points, now I have some connected points. Okay, so now if I have such kind of phenomena that comes into picture, then we are telling that that dynamical system is going to oscillate. Okay, and in the previous class we have already seen that in case of linear system, here I have again repeating the same linear system, and here you can see that in this particular linear system, if eigenvalue is completely imaginary, at that time what we found that I can transform that system something like alpha minus beta, beta into alpha, where this is the eigenvalue, and since eigenvalue I am assuming that alpha plus j beta, and if I have alpha plus j beta and if I substitute alpha equal to 0, then this reduces back to 0 minus beta, after that beta and 0. Okay, and in transform coordinate frame, what we found that we found very simple relation, that R remains R0, and after that theta is theta 0 plus beta t. So please check it from the previous class, and I can directly write in terms of solution. Since I have defined z equal to r cos theta, so in place of r I am going to substitute r0. Okay, because why I am writing r0, what we found that r dot equal to alpha, and here alpha equal to 0, it means that r dot equal to 0. So whatever initial condition of r, that is the solution of this. So solution of this, I can tell that RT equal to R0, and due to that reason this quantity comes into picture. And after that cos theta, and what we found that theta dot is nothing but beta. So solution of this is theta 0 plus beta t, and due to that reason this term comes into picture. Similarly Z2 I can define like R sine theta. Theta is theta 0 plus beta t. Okay, anyone has confusion till now? Now how to define R0? So R0 is nothing but the initial condition of Z1 0 and Z2 0 square of that, and theta 0 I can define by tan inverse Z2 0 by Z1 0. In this way I can define, and from this two equation I can able to plot also r dot equal to 0 and theta equal to theta 0 plus beta. And what we found that in this transform coordinate frame, and I have told you that that is nothing but coordinate frame, you can also interpret as a eigenvector coordinate frame. So in that particular coordinate frame you can see that I have some kind of closed orbit. So this is no trivial solution, because if I will take x dot equal to ax, then one kind of trivial solution, because here determinant is not equal to 0. You can check here that determinant, if you calculate, then determinant of this matrix is not 0. So due to that reason what happens that I have one trivial solution also, that is x equal to 0. Apart from that you can see that I have another solution. And why I am telling this as a one solution, because you can see here that if your initial condition is here and there is no perturbation, you are going to remain inside this orbit. Suppose if your initial condition is slightly different, then you are going to remain in this particular orbit. If your initial condition is like this, so that is basically depending on your initial condition, because Z1 0 square, Z2 0 square. So whatever initial condition you have, based on that initial condition you have certain kind of orbit. And what is beauty, if you start inside this particular orbit, you are not going to lose that orbit, and due to that reason their behavior is also equivalent to equilibrium point, or here I have infinite many equilibrium point or connected equilibrium point. You can also interpret like that, or some kind of invariant set. Okay, now you can see that whenever I have this kind of behavior, we are either telling that as a periodic orbit or some kind of closed orbit, and this oscillation is called sustained oscillation of amplitude R0. Okay, and this class of oscillator for linear system, when both eigenvalue on imaginary axis, that is called harmonic oscillator. Okay, let us try to see that is it possible to build that kind of oscillator or not. Okay, so I hope that you all have some kind of idea about the fundamental of electrical circuit. So I am going to take very simple circuit. I am going to take one inductor and one capacitor, and after that I am assuming that initially that capacitor has some kind of charge. Okay, so they contain some amount of energy, and after that I am going to connect that capacitor with some kind of inductor L. What is my fundamental assumption? That we are assuming that whatever capacitor we have, that is very ideal, means no dissipation kind of element is involved. Means whenever I am going to build that kind of capacitor, there is no resistance. Similar kind of assumption I am also assuming for the inductor. But in reality, that is not true. You all are already well aware about that. I cannot construct some kind of capacitor which doesn't has any resistance. That is means I think that is impossible. Okay, so some amount of resistance is there, and due to that reason, what happens that I cannot claim that whatever energy here that is always remains constant. Okay, but in ideal case, if there is no resistance, then overall energy of the system that remains the same because there is no dissipation. After that, if that is the case, then you can see here that if I apply at this particular point, if I apply Kirchoff's current law, then I can write IC plus IL equal to 0 because I am assuming some direction of current. You can assume whatever way you want. And after that, what I have done, that I have take the differentiation on the both hand side. So dic by dt and dil by dt equal to 0. And after that, what I have done, I have multiplied both sides by L. So if you multiply both sides by L, then L dic by dt, L dil by dt. Okay, and if you have phi equal to Li, and if you do phi equal to Li, I have, and if you calculate d phi by dt, then that is Vt and equal to L di by dt. So due to that reason, this term automatically comes into picture. I have multiplied with L, and here since Q equal to CV, so charge, whatever charge that is stored across this capacitor, that is given by Q equal to CV. So dq by dt equal to C dV by dt, and if you take one more differentiation of this, then d2v by dt square. So that kind of relation comes into picture. Anyone has confusion in this particular derivation? Okay, so what do you think? What is order of this differential equation or order of this system? Anyone? Baby Dina?
2, sir.
2. And Silpi, could you please comment that this is autonomous system or non-autonomous system?
Autonomous system.
Autonomous system. So in this way, you can see that autonomous system is quite obvious in nature. Okay, electrical circuit is also showing some kind of autonomous system. And after that, if you do the, since this is second order system, so I can apply the phase plane analysis. And after that, what I am going to do now, I am going to define the states. And from here also that is clear that why we have two states. Could you please, someone will comment why only I am going to take two states? Taslima?
Sir, because it has two energy storing elements.
Two energy storing element. Due to that reason, I have two states. Okay, so due to that reason, I have defined any two state variable because state variable notion is not unique. In today's lecture, we are going to see some example where I am going to tell you that how one can choose two different state space representation, but both are equivalent. So luckily, that example is involved in this particular lecture. Okay, so here you can see that I have represented system like this, and finally I have system like this. So you can also interpret this so automatically either you, if you solve this, then it is possible to show that eigenvalue is imaginary. So one can expect that using this I can able to construct some kind of physical oscillator, physical linear oscillator. But you can see that practically this combination is not realizable, and we have basically two different problems. And what is that problem? That whenever I have linear oscillator, so linear oscillator is not structurally stable. What does it mean? That if a small perturbation comes into picture, okay, and in previous class we have already seen that if I have some kind of system that is not hyperbolic, okay, hyperbolic system means those class of system whose eigenvalue is not purely imaginary. Okay, so if that is purely imaginary, then what happens? Due to some amount of parameter, system either become stable or unstable. We don't know what is the behavior, and due to that reason they are telling that that is not structurally stable. Structurally stable means if a small perturbation comes into picture, then it might possible that that oscillation phenomena is totally disappear. Okay, second thing is that amplitude of oscillation is depending on the initial condition. Okay, so you have to suppose that if you want to generate some kind of sinusoidal wave, so you have to fix the amplitude, and you all are knowing that whenever engineers or operator are fixing the initial condition, always there are some kind of error. So perfectly one cannot fix the initial condition, and if you are not able to do that, then what happens? You never able to get the required amplitude, because in case of linear system, each closed point is give some kind of orbit. So I have continuum of periodic orbit, and due to that reason, if your initial condition is slightly deviated, then amplitude of oscillation is going to change. And due to that two reason, we are not constructing oscillator based on linear control theory. You can see here that what is meaning of structural stability in case of LC oscillator, that since always some kind of resistance is involved inside the circuit, and due to that reason what happens, oscillation phenomena will disappear after some time, after finite time, that is disappear. And due to that reason people start looking towards some of the way to construct the nonlinear oscillator. Okay, so and what is main motivation? They want to remove these two drawbacks. And what is our drawback? Drawback is that whatever oscillator that we are going to construct, that should be structurally stable. Okay, so even if some small perturbation comes into picture, oscillation should not be disappeared. And you all are already well aware that oscillation is useful in several places. Okay, and after that I have to give guarantee that amplitude of oscillation at the steady state. Steady state means after some large time is independent of the initial condition. Means whatever my initial condition, whatever initial condition set by operator, finally I will come up to the steady state. And so in that way what happens, that there is no need to set the initial condition, you can just start your system. Finally in a steady state they will start creating some kind of required oscillation with some specific amplitude. Okay, so these kind of things we are going to look through in this particular lecture, and it is possible to show using the theory of nonlinear control system I can able to construct that kind of oscillator. But for that we have to see this kind of circuit, that is called tunnel diode circuit. Okay, and I'm not going to deep inside how to construct tunnel diode or these kind of things. If you have interest, then please just look through the Wikipedia. But just I'm going to understand tunnel diode in form of some kind of mathematical modeling. So what is beauty of tunnel diode? That if you see the characteristic, IV characteristic, so you can see from this expression that here that is not like the Ohm's law. In Ohm's law, if we are increasing voltage, then current is also going to increase, and after that some linear relation is there. But whatever H here, that is somehow some kind of, either you can take plus or minus, that doesn't matter. So some kind of function that map from R to R. So here H is not some kind of constant, that is some kind of function. Okay, and it is possible to show by seeing this characteristic. So I will show you first characteristic, and after that I will discuss. You can see here that initially if you are going to increase the voltage, current is going to increase, and after that what happens, that if you are going to increase the voltage, then current is going to decrease. Okay, and by increasing voltage, since current is going to decrease, and due to that reason people are telling that or interpreting that as a negative resistance. Okay, are you able to understand this point or not? Because in general circuit, if we are increasing the voltage, then current is going to increase. Okay, or in resistor kind of circuit. Okay, but what we found in this particular type of circuit, that initially their behavior is same like resistor, but after that what happens, that if you are going to increase the voltage, then current is going to decrease, and this portion is interpreted as a negative resistance. Okay, so that is the basically unique characteristic of this particular diode, and it is possible to show. Now what I am going to do, that first I am going to incorporate one tunnel diode and try to see their mathematical model and try to do some kind of analysis. Okay, so here you can just interpret this diode as a resistor only. Okay, they are not going to store some kind of energy, we are assuming here. So again my order of system remains the second order. Okay, anyone has confusion on this point? So here you can see that I have some kind of constant voltage battery source, here resistor LC, so I have connected RLC circuit, and after that I have some kind of diode, that is called tunnel diode. So I have diode and tunnel diode, so please be careful, both are different. Now what is our assumption? That capacitor and inductor are linear and time invariant. So if you are assuming that capacitor and inductor are linear, then only you are able to write this kind of expression. Most of time blindly we are writing, but assumption is that both inductor and capacitor are linear and time invariant, then only I can able to write like this. Okay, now if you go for the state space representation, since I have two energy carrying element, so capacitor is going to store energy in form of electromagnetic field, electrostatic field, sorry, and inductor is in form of electromagnetic field. So I have assuming x1 equal to Vc and x2 equal to IL, and U control action or whatever voltage that I have defined as a U. And after that what I am going to do, I am going to apply the Kirchoff's current law. So Kirchoff's current law I am going to apply here. You can see that this current is coming here, and these two current is going from here. So here sum of all current equal to 0. So if you take IC and IR as a positive, then IL become negative, and summation of all equal to 0. So incoming current is going is equal to outgoing current, and due to that reason I have this kind of expression. After that, now you can see that this IC means current through the capacitor equal to IR minus IL, and I have already defined IL as a second state x2. So in place of IL, and since I have shifted this whole things on right hand side, so plus x2, and IR, this is current through the tunnel diode, and we have already seen that current through tunnel diode IR is nothing but some function h, and after that is VR, and VR is the voltage, and you can see here, check here, that voltage across the capacitor, that is exactly same like this particular tunnel diode, and due to that reason I have this kind of relationship IR equal to H Vc, and Vc I have defined as a one state variable, and due to that reason I have this kind of expression. And if you use this kind of relation here, then finally I will get this kind of expression. Up to here anyone has confusion? Then please let me know. Okay, so I hope this is very simple. After that what I am going to do, I am going to apply KVL. Okay, KVL. So I am going to apply KVL in this particular loop. So I am going to take this particular loop. So here again come back to the circuit. So I have this kind of circuit, again same circuit I am going to consider, and I am going to apply KVL in this particular loop. And if you apply KVL on this particular loop, I am directly going to write now, because I think that this is very clear, and everyone are knowing this. So in this way VL I can able to write like this. Now you have expression of IL, you have expression of IC, you have a expression of IL and VC. So now what you can do, you can do the state space representation. So, and you know that VC equal to X1, and I have capacitor and inductor, and that is ideal. So I know that IC equal to C dV by dt, VL equal to L di by dt. Okay, so just you can substitute here, and after that what you can do, you can write the state space model. So this is the state space model. So please check it. Okay, now I am not going to do calculation. So this is my mathematical model of some kind of electrical circuit which contain RLC circuit and one tunnel diode. Okay, if you check the equilibrium point of this system, so equilibrium point, in order to calculate the trivial equilibrium point, I have to put x1 dot equal to 0 and x2 dot equal to 0. So if you substitute x1 dot equal to 0 and x2 dot equal to 0, then from here x2 equal to hx1, and if you substitute x2 here particularly, then you can see that this is my the equilibrium point. So equilibrium point is given like this. Now if you plot this, then it is possible to show that based on the operating condition. So if your operating condition is lying here, so I have three equilibrium point, Q1, Q2, Q3. If your operating condition is upper, then you have unique equilibrium point. If that is lower, again you have unique equilibrium point. So based on your region of operation, you have different equilibrium point. So this circuit is basically here reflected. I have three isolated equilibrium point. So you can see that I have one equilibrium point here, 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 if operating region is lie between here to here. Okay, so by just defining hx1, obviously hx1 is fully property of the tunnel diode. Based on tunnel diode, it is possible to show that I have three isolated equilibrium point. And so this example just confirm that whatever pendulum system I have considered that infinite many equilibrium point, and all equilibrium point is actually separated in two sets, but here I have three isolated equilibrium point. So for that point of view, this example is also relevant. Now what I am going to do, I am going to use the concept of this particular tunnel diode oscillator to construct some kind of oscillator. Okay, and since tunnel diode has negative resistance, I have already explained the meaning of negative resistance, and this oscillator is also called the negative resistance oscillator. So let us first try to understand the philosophy of any general nonlinear oscillator. So in any basic oscillator circuit, I have some kind of capacitor, some kind of inductor, and after that some kind of resistance element. And if you see the driving point characteristic of this resistance element, that should be like this. Okay, so here we are going to show you why I need this kind of characteristic. Okay, so by calculation we are able to understand that why this kind of circuit is required to generate the oscillation. Okay, so for time being, please do not worry and try to see that what kind of things basically comes into picture if I have this kind of characteristic. So what I am going to do, that first try to construct some kind of circuit, physical circuit, which will show this kind of driving point characteristic. Okay, and it is possible to show that if you connect two tunnel diode, then I get this kind of characteristic. One tunnel diode, we have already seen the characteristic. If you connect two tunnel diode, then this kind of characteristic comes into picture. But that is not using tunnel diode. You can take some chemical equations, and using that also you can create this kind of characteristic. Then that is chemical oscillator. if you will take some kind of mechanical system and construct this kind of characteristic, and if you replace C and L by by their equivalent, means mass spin damper, so you can select based on the equivalence, then it is possible to show that one can also construct some kind of mechanical oscillator. Okay, so theory is quite general. Okay, you have to just construct two storing kind of element, and after that which can exchange the energy, and you have to build some kind of driving point characteristic that is looks like this. And why this kind of characteristic is required? Because the resistance element is an active circuit characteristic. Active, what is meaning of active circuit characteristic? If you see the resistance, so always they dissipate the energy, but whatever negative resistance, so they can actually also give some amount of energy, and whenever someone is able to provide some amount of energy, that is called active element. Okay, so resistance is works like active element, and philosophy is very simple, because if you connect C and L, so C and L always has some kind of resistance. So if some energy is dissipate across the resistor, so you have to provide some kind of equivalent energy. Okay, then what happens? Some sustained oscillation comes into picture. That is the basic idea. Whatever energy that is going to dissipate across the resistor, you have to supply same amount of energy. And how to do that? You have to construct some kind of resistive element which can works like some kind of active circuit and provide some amount of energy. And if you see the characteristics, so from the characteristic also it is obvious that H equal to 0, that should be 0, and after that, that will, if V tending towards infinity, so H is also tending towards infinity. If V tending towards minus infinity, then H also tending towards minus infinity. And if you see the slope, so slope of this should be negative in vicinity of equilibrium point. So similar kind of things, means this is the characteristic. And why this is general characteristic people has provided? Because suppose if you have to construct some kind of biological oscillator, or some kind of oscillation phenomena occur in biology and in our body, at that time also they will satisfy this kind of characteristic one only. So this is very generalized, and here meaning of H dash is dou HV by dou V. So with respect to V, I am taking derivative, and I am taking derivative in neighborhood of equilibrium point. That is the meaning. Okay, so this is the characteristic of the active element, and now you can see that VI characteristic can be realized using this kind of twin tunnel diode. Again, I am not going to how basically this kind of characteristic comes into picture, but just you can, for your information, you can connect to the tunnel diode circuit like this. It is possible to show that similar kind of characteristic comes into picture. Okay, so those who are working on construction of oscillator, they are basically using this kind of circuit. So this is just for the intuition. Now what I am going to do, I am going to take that circuit. So I have what we found that I have capacitor and I have inductor, and after that I have certain kind of resistive element here. Okay, so if you assume that current here is I, here in this is the inductor IL, and this is IC. So you can see that again, if I apply here the Kirchoff's current law, then I will get this kind of expression. And after that, just by fundamental theory, you can able to write that IC equal to C dV by dt, and I hope that IL you can able to calculate like this. Anyone has confusion why I have written IL like this? Anyone? So you can see that phi equal to Li, and after that you know that d phi by dt equal to L di by dt. So from there you can able to generate this kind of expression. Anyone has confusion, then please do that exercise. And I is HV. Okay, after that what I am going to do, I am going to, since I have, this is not a differential equation, this is differential integral equation. So what I am going to do, I am going to take again derivative with respect to time. So if you will take derivative with respect to time, then you can see that I have this kind of expression. Again here H dash V means tau hv by tau v. Okay, so I have this kind of expression, and here you can see that again my system is of second order, so I can represent this system using some plane. And if you see this expression, so this expression is connected with the Leonard equation. Leonard equation is very famous equation that is coined by some mathematician, and they are telling that what is characteristic if I have this kind of general equation. So this is nonlinear function and this is nonlinear function, but here you can see that luckily if you see GV, so GV somehow represent V, this is linear, no longer non-linear, but still I can interpret the generalization of this particular expression, whatever oscillation expression I have created, that is equivalent or that can be derived from this generalized equation. Now what I am going to do, why I am going to establish this kind of expression, that Leonard first taken this expression and after that they have changed the time variable. Okay, so they have scaled it out, and what they found that it is possible to express this expression, whatever expression I have, in some simple form. So I am going to represent this expression in some other time scale, and I have defined the time scale like tau equal to tau by root CL, and that is motivated by Leonard equation only. So it is possible to show that dou V by dou T equal to root CL dV by dt. Okay, so everything is very simple. Initially you have something tau here T is here. Now what I am going to do, I am going to take calculate dou V by dou T. Initially I have dV by dt. So please check it. This is straightforward. Okay, after that now what I am going to do, I am going to take the second derivative. So it is possible to show now in that particular time domain I can able to again come up with this expression like this, where epsilon is given like this. Okay, and what happens here, if you select HV in some specific way, then again I have very fundamental equation that is called van der Pol equation. Okay, so in van der Pol equation, van der Pol has suggested that one can construct this kind of function minus v 1 by 3 vq. You can see here what is main motivation. So if you are inside the unit cycle v equal to less than 1, then this term might be dominant over this term. So they have some kind of, or if you see the rate of change near the equilibrium point, at that time h dash less than 0. So please check it. Okay, why that is less than 0? You can see that dv by dv equal to minus 1, and after that here 1 by 3 and 3 is going to cancel out. So I have minus 1 plus v square, and if v is very small, means near to 0, then slope is minus 1. Okay, after that if you plot this function, it is possible to show that if v is tending towards infinity, this is also tending towards infinity. V is tending towards minus infinity, then this is also tending towards minus infinity. So this is one of the function that is constructed by van der Pol. Okay, so if you are going to replace this kind of function, then whatever oscillator comes into picture, that is called van der Pol oscillator. Okay, and it is possible to show that initially we are using vacuum tube a lot. Okay, in order to construct television, lot of places we are using vacuum tube in initial phase of our electronic circuit, and it is possible to show that whatever oscillation that is going to occur inside the vacuum tube, that is represented by this van der Pol oscillator. It means that if somehow I will set the active element or resistive element which characteristic HV equal to minus V plus 1 by 3 V cube, then I can able to model the oscillation inside the vacuum tube. So this become very famous, that van der Pol oscillator, because at that just 10-20 years before we are using vacuum tube a lot, and due to that reason van der Pol oscillator become more famous, and people has also able to understand how to construct the oscillator, particularly why vacuum tube are doing some kind of oscillation. Now what I am going to do, I am going to write this particular expression in a state space form. So now if you see the state space model, then in that particular circuit I have resistor, capacitor, and after that one active resistor. So I am going to assume here x1 as a V and x2 dot equal to V dot. So first state space form, I am just going to take a state variable as a voltage, and after that what I am going to do, that voltage across either you can either you can tell that capacitor, or you are tell that inductor, that remains the same, and whatever active element, so voltage across all three are remains the same. Okay, so basically I am going to take that voltage and rate of change of that voltage as a another state variable. So you can see from here. So now I am not going to concentrate on bundle pole oscillator, because we already understood that what is relation of bundle pole oscillator and this particular generalized oscillator. Whatever we have actually whatever expression we are getting here. Now I am going to represent that as a state space representation. So I have second order equation. So two state variable is enough to represent this system. So due to that reason, I am going to represent my system like this. Okay, so quickly we will come to the state space representation. So in a state space representation, I have second order system. Okay, second state space representation I can assume like this, because more physical relevant variable is that current through the inductor or voltage across the capacitor. Because I have two storing element, so I have taken, so this is natural suggestion of a state space, and I am going to show you that these state space representation as well as these state space representation both are equivalent. Okay, one can transform from one state representation to another state representation, and I have already told you that this will also give you idea that why state space representation is not unique. So if someone tell you that give some kind of example where state space representation is not unique, you can also give this kind of example. So this is very much physical example where we are able to see that state space representation is not unique. So here I am going to now take more relevant or physical quantity, because V and V dot is not so much physical quantity, but at least IL and VC both are physical quantity. I can interpret voltage or rate of change of voltage, but that is not so much relevant, because we know that energy is stored in form of voltage in case of capacitor, in form of current in case of inductor. Now if you write like this, now in this particular state space coordinate, here I can able to write this expression. And what is main motivation of this expression? You try to see that I know that phi equal to Li, so d phi by dt equal to L di by dt, and d phi by dt is nothing but voltage across the inductor, and we know that voltage across the inductor, voltage across the capacitor all are equal. Okay, so d phi by dt equal to V, so I can replace this by Vc, and that is equal to Z2. So Z2 equal to L by di by dt, and I know this I equal to IL, and that is Z1. Due to that reason this expression comes into picture. Anyone has confusion? Okay, now what I am going to do, I am going to derive the second equation. So that is the dV by dt. So I know that dV by dt is actually, I have Q equal to CV, and after that dQ by dt equal to C dV by dt. So dV by so dQ by dt is current. So current, this is current through capacitor, and I know that current through IC plus IL plus I equal to 0. So if you substitute inside this, then you will get this expression. So please check it. Okay, so same differential equation can be represented in two different coordinate frame, and after that what I am going to do, I am going to change this particular differential equation in another time frame. So I am going to scale time by t by root under LC, that is just from the linear equation, and after that you can see that I can represent system like this way. So in Z1 Z2 coordinate I can represent system like this, where epsilon I have defined root under L by C. So I have one representation like this where Z1 and Z2 is physically relevant state space variable, another in terms of V and V dot. It is possible to show that both are equivalent. It means that you are able to make some kind of transformation. You can define some kind of transformation Z equal to Tx where x1 equal to z2 and x2 equal to like this. So please check it. Okay, I am not going to do calculation again, and after that similarly I can able to go to reverse back. So this example I have just done here, because if you are going to express some system in different coordinate frame, it is possible to show that almost all coordinate frame can be equivalent if there exists some kind of transformation, some kind of invertible transformation. Okay, now let us come back to the original equation. So I have expressed my system in V and V dot coordinate frame, and there now I am going to check the whole expression. So for time being, please just quickly return back to that particular equation in original coordinate frame x1 and x2. So this is expression in x1 and x2. So in order to calculate equilibrium point, what I have to do? I have to put x1 dot equal to 0 and x2 dot equal to 0. So if you substitute x1 dot equal to 0 and x2 dot equal to 0, now you can see that after substituting x1 dot equal to 0 and x2 dot equal to 0, my situation is like that x1 and x2 equal to 0 as the equilibrium point. So just you can check. So this is nothing but trivial equilibrium point. Okay, now what I am going to do, I am going to calculate Jacobian across this equilibrium point. So and in previous class you have already seen that Jacobian is dou f1 by dou x1 dou f1 by dou x2 like this. So if you do this and calculate the eigenvalue, say so based on epsilon, okay, h dash 0 I can fix, and I know that h dash 0 is always negative, so this become positive. So based on epsilon, it is possible to show that your equilibrium point is either unstable node or unstable focus. So if that is unstable node or unstable focus, that is depending on epsilon multiplication with h dash 0, then it is possible to show that trajectory is not going to remain here. They will diverge either in form of node or in form of the focus. Okay, so that is going to diverge from here. Okay, now what is remark? So remark is that repelling feature is due to the negative resistance near the origin. So this kind of repelling feature comes because h dash 0 is negative. If that is positive, then this kind of behavior will not come. Okay, and we are interpreting that resistor is actively supplying the energy. So due to that reason, we are going to check the rate of change of energy. And you are all are well aware that I have two storing element, so energy can be given like this. Okay, now what I am going to do, I am going to, in place of Vc, I am going to substitute Vc equal to x1 and IL equal to this, because we know that both coordinate frame z1 z2 and x1 and x2, and we have also established the relation between that two. So using that relation, I have defined Vc and IL. Please check it, the equivalence. And after that, what I am going to do, after that I am going to substitute that, and after substituting this, I am going to calculate the rate of change. Okay, so rate of change means just I am going to take differentiation on both the right hand side and left hand side with respect to time. And if you take the differentiation, it is possible to show. So please check, please do calculation whenever something is written. So since this is I am not teaching with chalk and talk, so during chalk and talk calculation is obvious, we are doing calculation, but here everything is done, so you have to check it. So here x1 and x1 dot, and similarly the derivative of this with respect to time. So finally it is possible to show that comes like this. Okay, now if that comes like this, try to see here epsilon is root under L by C, so that is positive. Capacitance is always positive. So sign of this signal, this is nothing but d by dt we are telling. So sign of d by dt means rate of change of energy is totally decided by multiplication of x1 into hx1. And we know that driving point characteristic, that whatever curve, that should be looks like this. Okay, and here x1, I have axis x1. So if you multiply x1 into hx1, it is possible to show that if you multiply these two, so since x1 is positive, and what happens, I have negative sign here and x1 is positive, so negative, 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 and x1 is positive, hx1 is negative, so negative, negative, that is positive. Due to that reason, graph is shifted on positive side in this particular region, means whenever this is negative, then graph is shifted on positive region. Okay, similar kind of things in the similar logic, you are able to understand here that actually in this particular side, if you check carefully, then x1 is now negative, and what about hx1, that is positive. So again in this side, this graph, dotted graph, that become positive. Okay, so what happens, that rate of change become positive in this particular region from minus a to b, and after that rate of change of energy become negative. So rate of change is positive, means we are supplying the energy. Rate of change is negative, means we are dissipating the energy. And due to that reason, what happens, some oscillation kind of behavior comes into picture. So remark is that the strip boundary, so I have boundary minus a to b, solution, and how to calculate this boundary. If you solve hx equal to 0, then that will give you the boundary condition minus a and b. Okay, I am quickly finishing the lecture because I know that you have next class. So as a trajectory move in and out the strip, there is exchange of energy, and trajectory somehow gaining energy inside the operating characteristic and losing energy outside the operating characteristic, and due to that reason I have certain kind of oscillation kind of phenomena comes into picture. That is the interpretation, and in next class we are also going to see some more mathematical expression for that. So one of the famous periodic orbit, that is also called limit cycle. Limit cycle means some kind of periodic orbit. If you start anywhere, you are going to converge to the same orbit, and again they have behavior like t equal to xt, like this periodic orbit behavior. Okay, so limit cycle is nothing but some kind of oscillation that is produced by some kind of nonlinear circuit. Okay, so here one of the expression that is coming from van der Pol, that is given like this. So a stable limit circle means if you start in nearby of equilibrium point, then all trajectory will diverge. So that is locally unstable. But you can see here, if you start from very far point, then all trajectory is converging towards this invariant state. Okay, so meaning of limit cycle is that something if locally unstable and globally stable. Okay, and here this is unstable limit cycle. Why unstable? If you just change the sign here, in place of x2 you can substitute minus x2 and x1 and minus 1, then it is possible to show that if you start here, then all trajectory is converging towards the equilibrium point, and if you start here, then you will diverge. So this is called unstable limit cycle. So let us come to the conclusion. In this particular lecture, I have talked that how to model the nonlinear oscillator, what is limitation of the linear oscillator. Okay, we have also seen that some kind of physical circuit which has two different state space representation and both are equivalent. We have also seen that in case of tunnel diode, I have multiple isolated equilibrium points. So with this remark, I am going to end the today's lecture, and if you have any question, then please let me know. Anyone? Okay, if you don't have any question, then I am going to end the today's lecture. Thank you very much. So I will take next class tomorrow.